Are you taking AP Environmental Science? I hope you do really well in the exam. I can't help you. I don't know anything about it, but Mr. Smeeds from Apes versus Everybody does. So if you, yeah, we'll find ourselves on here somewhere. Jordan, how are you doing tonight?
I'm doing great. It's getting lighter out, which means more biking time for me. I'm about to hit the trail for about 5 days on spring break. My buddies and I are going to bike from the Natchez Trace Parkway, so I can't wait.
That sounds very AP Environmental Sciencey to me.
That's right.
People who like teaching history and literature, we spend our breaks watching period dramas and reading things.
Yeah.
And not getting on bikes. Jordan, one thing I want to share with everyone who's taking AP Environmental Science, if you don't currently follow Jordan's YouTube channel, definitely I'll be putting this link in the chat for all of you. And welcome everyone who's joining live. If you are here with us live, definitely post your questions in the chat. If you're watching the recording, post those in the comments, and Jordan and I will come in and answer. If you don't follow Jordan here, this is an incredible page. Jordan, what are some of the things I can find on your page?
Great question. Topic, 8 to 10 minute, 8 to 12 or 14 minute topic videos for every single thing on the exam. So in short, all the basic content is covered. You definitely want to practice writing FRQs, but from the standpoint of just what do you need to know, it's all here from a base level, vocabulary, concepts. So you can see they're all sorted out by unit. So of course, you have 7 and 8, noise pollution, atmospheric pollution, water pollution, all the way up to unit 9, climate change. So you've got it all there. There's a little bit of FRQ writing strategies sprinkled in as well. If you see Think Like a Mountain, Write Like a Scholar somewhere in there, you go to the Write Like a Scholar playlist series. We've got that. So that's explicitly going to go through with you, how do you write better FRQs? There will be more of those coming in the future to make sure we're really honing in on the exact format of this year's FRQs, since this will be the first year of a new redesign. So 3 FRQs, slightly different formats. And so, yeah, throughout the month of April, there will be more specific FRQ writing strategies now that the note series are finally done.
Great. And then if I follow you on Instagram at Apes versus Everybody, you guys can see this AP Environmental Science versus Everybody. What are some of the things that I get here? Like I see this thing on thermal inversion. Actually, it looks like, yeah, go ahead.
Yeah, you get a tiny bit of humor sometimes in the captions if I'm feeling creative. Sometimes you just get what I call hashtag apes knowledge. What I try to do is put tricky concepts in the captions, concepts that students I know are likely to make mistakes on. I hate to see ape students make mistakes, especially predictable ones. And so we also know just from research and anecdotally that something that makes teachers more effective is when they tell students the mistakes they think they might make ahead of time. So I really strive to do that because nobody likes to see students make mistakes that they already think they might. And so we just try to point those things out. All of those slides, though, are basically the slides from the videos optimized for an Instagram view. And the way I encourage people to use it, and I'm really glad you're scrolling through it right now, is essentially to look at like the second post in any post. So if you just click on one of those, doesn't really matter which one, and you go to the second post, this is going to have what is called the essential knowledge. This is what the College Board says you have to know. Now, it's not every single thing, it's not the textbook, but it's basically what are the must know concepts. I really like that phrase, must know. What can you bank on to be on the exam? And that's it there. So what I like to encourage students to do is look through those and kind of try to elaborate on them or try to expand on them. Get your dog or your younger sister or your younger brother and try to explain soil conservation to them. Grab a parent and just glancing at these, basically give yourself a mini quiz. See how well you can explain this, and then scroll through the slides and check yourself to see, are you on the right track?
That is great. And one of the things, so if you don't follow Jordan at Apes versus Everybody, go ahead and do that on Instagram. A great account, a really great way to take your social media time wasting and actually make it really productive and helpful for you as you're binging on all of this. And of course, this is not time wasting. This is a rich treasure trove of videos on his channel. So both of those links are going to be in the description for everyone. Jordan, tonight we're talking about Unit 6, Part 2. Remind me, what is Unit 6 about? What's the high-level topic we're all going to be discussing?
Great question. So in Unit 6, Part 1, we talked about fossil fuels, non-renewable energy sources. In Unit 6, Part 2, we get to the renewable energy sources. This is a pitfall of many students who just like to call it clean energy or green energy. We don't want to call it clean or green. We want to call it renewable. And then we want to be able to speak about different types of renewable. So that's our goal today, is for you to leave not calling it green energy or renewable, and actually being able to describe how is electricity generated from wind, solar, hydro, all of those things. So as we get rolling here, make sure to check out Marco Learning on their socials if you haven't already. Great TikTok content, phenomenal YouTube content. That's where you're watching this, so you're already familiar with where they are. But check them out, especially on TikTok. John is just putting out some great content there. My socials are here. John went through those with you already, so just make sure to check those out. I think most of the folks here are, dedicated people that are probably already on these, but check them out if you haven't yet. Great content, basically every day on Instagram and a couple times a week on YouTube. What are we covering today? Kind of mentioned this already, but one thing I try to do as a teacher is address the common FRQ mistakes I think that you'll make before you make them. And so everybody likes to be aware of the pitfalls that they might have on the exam and really how to avoid them. And if you know ahead of time what they are, my hope is you can avoid them in May and get the best score possible. We'll focus on a little content, Unit 6 energy review, and then the how to study. We kind of did it at the beginning. I really recommend using Instagram and using your notes and giving yourself little quizzes to see what you can recall, and then basically checking yourself. So we will wrap up though with some study resources at the end. Very quick info that I'm just gonna breeze through again because we've had it each week and I think you guys are aware of this, but there's 3 different exam administration periods. You have to reach out to your school's AP coordinator. They'll let you know which option you're using. Then if we look at the format, and this ties right into AG's question. AG, thanks for being so dedicated. I think this is probably the 5th straight review that you've attended, so well done. So these FRQs this year are a little bit different because there will be 3 FRQs in 70 minutes instead of 4 FRQs in 90 minutes. So they've removed 1 FRQ and they've cut your time down 20 minutes. So you're now down to 3 FRQs in 70 minutes. The structure of the FRQs has not changed much. They're quite similar, but we do have a little bit more detail in terms of what they will be. We know you'll have to design an investigation, fancy word for an experiment. We know you will need to analyze an environmental problem and calculate a mathematical solution. So you'll have to do some math. That will probably be 6 out of the 10 points, 5 out of the 10 points. And then you'll have to analyze an environmental problem and a solution to that problem. So if you struggle with calculations or you struggle with investigations, please go back to Marco Learning's channel and check out the reviews or the replays of our previous reviews, because we went through experimental design 2 weeks ago. We went through calculations last week. We'll brush up on calculations again this week, but today we'll really be focused on environmental problems and then proposing a solution. So AG, hopefully that kind of clears up your question there. So the link tree here is something I think was already shared. Has all of the resources, but we'll be revisiting it at the end of class. At the end of class, I sound like I'm still teaching on Zoom school. At the end of the video here. And then another clarifying question here for AG. What's nice about this year's exam is every single question will have one of these 7 task verbs. And that tells you what your answer has to look like. So the College Board has taken a lot of the guesswork out of the equation. You're going to be asked to describe, explain, calculate, identify, justify, propose a solution, or make a claim. And if you do what this task verb tells you to from a structure standpoint, you put yourself in a really good position to earn points. What you don't want to do is be too brief on a describe or leave out, evidence on a justify or propose a solution. So super key that you follow this task verb sheet that I've put together that really kind of hones you into a specific answer on your FRQs. So common FRQ mistake number 1. This is a mistake that students make, and it pains me, and I hope that you don't make it in May. So hopefully going into the exam, if you already have checked out these slides and thought through this, you're less likely to make this mistake. That mistake is not connecting your answer to an environmental problem. And so oftentimes you'll be asked, what's an environmental problem of X? And you need to actually firmly connect your answer and an environmental problem. You can't leave it implied. You can't assume that the reader knows that fertilizers are bad for the Gulf of Mexico. So let's take a look at an example. Describe 2 environmental impacts on the marine ecosystems that are caused by fertilizer as it flows into the Gulf of Mexico. We do not want to say something like fertilizer flowing into the Gulf of Mexico can cause water pollution in this ecosystem. Water pollution is just too vague. So instead we could say that it will cause excess nitrate levels. Now we've said a specific pollutant, but we still haven't connected that specifically to an environmental problem. That's where the second sentence is so important. Elevated nitrate levels can lead to an algae bloom that will block the sun from reaching other plants beneath the surface, limiting photosynthesis. So look at what this second sentence does. It gives us a specific environmental problem. If we go back one slide, look at the task verb sheet. The reason that I ask students to push for 2 sentences in a describe prompt is that you need some basic key details that expand on the topic. You need a link back to the prompt. If you just give 1 sentence on a describe, you may be leaving critical details out. So look at that second sentence. Elevated nitrate levels can lead to an algae bloom that will block the sun from reaching other plants. Now we've limited photosynthesis. That is an environmental problem, and we've now earned this point instead of leaving it stranded. Great example of just what it means to actually visualize this process. So think it through step by step. Excess nutrients in fertilizer means runoff into water sources like the Gulf of Mexico. It means algae grow on the surface. It means that we're blocking the sun, and now those plants beneath the surface die because they can't photosynthesize. So really trying to visualize in what I like to call your mind's eye, thinking in your head, what are the steps I have to walk through to get this describe point, to connect my answer of excess nitrate levels back to the prompt of an environmental problem. So just a great way, again, to kind of think, like, what would this actually look like in a step-by-step process? Another example is identify an energy source commonly used to produce electricity that also causes acid rain. Describe how it causes acid rain. Again, we're connecting our answer to an environmental problem. You may be tempted to say coal is burned, which leads to acid rain due to the sulfur in coal. So we've given like a hint of a reason. We've said there's sulfur in coal, but saying that there's sulfur in coal doesn't quite link us all the way to acid rain. We're missing that second sentence. This is the worst thing you can do on a describe FRQ is answer with 1 quick sentence and not elaborate at all. You just need some elaboration to connect sulfur and coal to acid rain. How do we get there? We're missing the link in this first red, rectangle kind of crossed out answer here. So we could use a similar answer in the right. Coal is burned. That leads to acid rain due to the sulfur dioxide. Now we're not just saying sulfur, we're saying SO2 released by coal combustion. That SO2 combines with oxygen and water in the air. That forms sulfuric acid. That sulfuric acid gives off H+ ions, and H+ ions are what actually makes water acidic. Remember that pH is the measure or the concentration of H+ ions. So the more H+ ions in a body of water or in a droplet of rain, the more acidic it is. Now we've connected those gaps that we had in the first question. In the first answer, we just had sulfur and coal, acid rain. We had nothing filling us in to bridge that gap to actually get there. So again, think through those steps, step by step. We have the coal power plant. We have the SOx emoji to help you remember the SOx, or the sulfur dioxide is released. It mixes with water and oxygen in the air. Then we can form sulfuric acid, and that adds those H+ ions to the water. So again, visualizing the steps is huge. Mistake number 2, we describe oftentimes solutions that are either vague, they're too non-specific, or they're actually impossible. They're things that the government can't do. And so here's a great example. Describe a method for reducing the cause of acid rain we just talked about in part E. Now remember, we talked about coal and sulfur dioxide. So students will often write, the government can raise the price of coal so that there's fewer SOx emissions. The government can't just raise the price of coal. They can't just call up the coal market and say, coal is now $1 million an ounce. They just can't do that. They don't have the power. It's not the way that a capitalist country works, or really most countries on earth. And so we really need to steer away from these vague kind of generalizations and go to things more specific. A great thing that a government can do is a tax credit. So if the government gives a tax credit for solar energy plants, now the cost of solar energy or solar electricity becomes lower compared to coal. Because it's lower compared to coal, less companies will use coal. There will be less coal combustion and less SOx emissions, fewer SOx emissions. So now we've been specific. Hey, Kimmy, thanks for tuning in. Will there be paper provided for the digital exam? I'm not totally sure what you mean. The digital exam will be online in basically a testing interface, and Marco Learning has some great review videos where John goes through how do you actually use that interface. We'll definitely try it in class. I think other teachers will be trying with their students as well. But check out John's content on both TikTok and YouTube on what does that interface actually look like, because it will all be totally digital. So let's take a quick look at calculations because it's very likely that we'll have percent change calculations to do on the exam in May. And so we're going to just practice one of those quickly. This is one my students and I just did today. And so remember that in percent change, it's the new value minus the old value divided by the old value, and then you do that, quantity in parentheses, and then you multiply the whole thing by 100 at the end. And so a great example here is this calculation problem. Calculate the increase in MSW, which is municipal solid waste, from 1980 to 2012. Now we know 2012 is the new value because 2012 is more recent than 1980. So we look at the graph and we see that in 1980, there were 150 somethings. Now here's what's really key. We have to be precise. We can't just say 150 and 250. 150 what? 250 what? Goldfish, popsicles, degrees, like what do these labels mean? So we have to look over at the y-axis here, and we see if we tilt our heads and read the y-axis, it's 150 million tons, and we need to include million tons. Let's see, Tom Ritchie or John Green. I'm not sure what you're referring to, Hudson, but those guys are both awesome, especially for social studies classes. And then Kylie, we will have to see if I can link these into the link tree later. That would be a great thing, so you can see them. But yeah, also you can go and check out this replay to see these slides later. So if we actually work this math out, 250 million tons, the new value, minus 150 million tons, the old value, divided by 150 million tons, the old value again is going to equal 0.66 times 100 is a 66% increase in municipal solid waste. So let's take just a very quick question / brain break. You have another meme to enjoy here about the challenges of doing math. So take a look at that one, see if you get a chuckle out of it. And we'll just take a quick break, see what questions folks have, and then we'll go on with some content review. Will we get points off if we don't label the numbers we use? It's very possible, Una. It's really, really, really a good idea to include units. And so let's just go back for 1 second. You definitely want to include that this is millions of tons. If you look at the scoring keys for released exams, they always include units, and they always specify that 1 point will be earned by the correct answer with setup. Sometimes there's a point for the setup and the answer, but now we're trending in the direction of mostly just 1 point for both setup and answer.
Jordan, this is great. We're getting a bunch of great questions and comments. I want to welcome everyone who's joined us here for the live. If you're enjoying this video, definitely press that like button, subscribe to our channel. Jordan, I just have one general question for you in the context of all the AP exams. And
sure.
Guys, you can let us know in the chat. Are you taking other AP exams? Have you taken other AP exams before? Because one of the interesting things to think about is how different the free response sections act on the different exams. Like some exams, you have these really nuanced points, all these like different ways of getting points, and can you get the point, can you not get the point? It sounds like You've got some key strategies for the FRQs we need to follow, but this is not as complicated as AP English Literature or AP. Is that accurate to say that it's focused on the tasks and what you need to do? What does that difference look like to you?
Yeah, that's incredibly accurate. There's no elaboration points. There were in the dark days of 2002 and 2003, you had these bizarre, like, if the student gives an exceptional description of eutrophication, will maybe award a bonus point for their massive brain. Luckily, they do not do that anymore. It's wonderful, actually, because it's so clear. When you look at, again, we're just going to flip back through a lot of slides here for a second to just see the task. When you look at this, whatever you're asked to justify, if you've given 2 to 3 sentences and if they are accurate, if there's some evidence that explains how your justification supports the claim that you've made or the statement, you should be earning that point. There's really not this ambiguity or this vagueness of, did the student use the right diction? Did their idea sound complex enough? I have scored exams for the APES exam, and what amazed me is how some students who write at a really high level of vocabulary and sound really intelligent don't actually provide the step-by-step process, and they miss a point. And then another student maybe doesn't write quite as like flowery, their diction isn't quite as impressive, but they're clearly just walking through the steps of a problem. They're linking their answer directly to an environmental problem. It's a tiny bit clunky. They're like, even like a verb tense might not even be quite right, or an article, might be missing, but they earn the point. That's what I love about APES is it's so centered on just, do you know the basic environmental concepts, and can you articulate them in a step-by-step process that fits with these task verbs? When you're asked to describe, can you describe? When you're asked to explain, can you go the extra mile to connect the dots and circle back to the prompt? If you can, you're in really good shape. And you don't need to write a thesis. You don't ever need an intro sentence. You never need a concluding sentence. You don't have the time for them. It's really nice that it's just so straight in, straight out, and you just move on to the next question.
That's really encouraging for everyone, because we've got a few people here, AG, Kylie, who are taking a full stack of AP classes.
Holy smokes, yeah.
The way that you guys approach those, especially Lang,
yeah,
complexity point in AP US history and in AP world, is a different thing, and that will help you guys as you're preparing for multiple exams. In fact, everyone, I'm going to be going live on this channel a little bit later at 8 o'clock Eastern to talk about how to develop a study plan. And when I go through that, I've been helping students for a very long time with this. You're going to sort APES in with computer science and in with English, that I think is going to be really valuable.
Yeah, I'm going to say one last thing quickly here as I look at the exams people are taking. AG, this exam is going to be similar to psych in the FRQs. Granular, so you're kind of focusing on one piece at a time. If you include the basic components for each answer, you're going to be great. I cannot speak to Lang. I haven't taken it or taught it. I know there's quite a bit of complexity and nuance that goes into those essays, those FRQs. I have talked to our AP Lang teacher at our school, and I know it is quite complex. So you do not want to write the way you would write an AP Lang on APES. Similarly for APUSH, I know in APUSH there are theses that you need to reference documents sometimes. I took the APUSH exam. I won't tell you when, so you don't, know I'm a million years old, but it's a different type of writing. The nice thing about APES is it is an easy course to write for, in the sense that you just go straight to your point, 3 sentences at the absolute most. You never need more than 3 sentences for any given, single point. Oftentimes 2 complex sentences will get you there. And so then again, to Kylie, just make sure that you differentiate clearly your AP World and your AP English and your APES style of writing. If anything, APES is a nice breather, because you're just really going right in and going right out. So I can't say enough about how formulaic it can be if you really know your task verbs. So let's get on with a little bit of content review. John's going live at 8 here. He's going to be working through, how do you actually set up a plan, which is an awesome video. If I were taking AP exams this year, I'd be, going for a bathroom break, stretching my legs, and coming right back at 8 o'clock. So We're going to quickly go through some APES content so that you leave feeling like you understand renewable energy a little bit better than you came in. And then, we'll be wrapping up here in the next 15 or 20 minutes. So like I said, you can take a break, stretch your legs, and come back for your study planning at 8. Just want to quickly check AG's commentary here. Yeah, it's very similar to AP Psych. And what is really nice, this I'm glad you brought this up, AG, is that AP Environmental and really any AP class can help you in Lang and to some degree in Lit, but more so in Lang, because in Lang, the prompt could cover almost anything. And so sometimes having that content knowledge just makes you more comfortable. So I really hope that is the case for you guys this year, that you get lucky and APES content happens to be on your Lang exam. That would be sweet. Knock on wood. And hopefully, you get to write about eutrophication and fertilizer in the Gulf of Mexico. So going into renewable energy, though, in case they ask you about that on your Lang test, the big thing we need to know is that renewable energy sources do not release greenhouse gases when generating electricity. And that's important to note. They do generate greenhouse gases when you're building the plant or when you are mining for the materials that might go into those devices or those plants, but not when you're generating electricity. That's an important distinction. Now, fewer greenhouse gases means less global warming. They also don't release particulate matter, SOx, NOx, VOx when you're generating electricity. Notice I didn't say that they don't release air pollution. We really want to strike air pollution from our vocabulary. I like to tell students air pollution doesn't exist. It's not a thing. It's an idea. And so you never want to write about air pollution. You want to write about air pollutants, PM, SOx, NOx, VOx. Those are 4 big ones. So why do fossil fuels release greenhouse gases and air pollutants? The thing we need to know here is that fossil fuel combustion is a burning reaction. We're adding heat, we're combining oxygen with a hydrocarbon fuel. So I like to tell students as well, kind of follow the atoms. Don't try to memorize everything. Remember that hydrocarbons, fossil fuels, have carbon and hydrogen. When you burn them in the presence of oxygen, which is what a combustion reaction is, you're going to produce carbon dioxide. Some of those oxygens from the atmosphere are going to combine with some of that carbon that's being broken down by this reaction, and that's going to produce CO2. Oftentimes, there are impurities like a little bit of sulfur, a little bit of nitrogen. That's where you get the SOx and the NOx. Particulate matter is just the little bits of matter that come out of the fire. So if you think through, what does a combustion reaction of fossil fuels actually look like from an atomic standpoint or a molecular standpoint? It's so much easier to remember, oh, that's right. They release carbon dioxide, follow the carbons. They release NOx and SOx because there's a little bit of sulfur in coal. There's nitrogen as well. It's dead biomass. And so when you remember that, I think it's easier to really know why fossil fuels release these pollutants instead of just having to memorize this laundry list. So I always strive to help students understand more, memorize less. That's kind of the motto here. So let's talk about nuclear, because nuclear fits into this weird kind of category where it's lumped in with the fossil fuels because it is non-renewable. So nuclear energy is based on uranium. It's a radioactive element. We have to dig it out of the earth, and there's limited amounts of it. We will run out of uranium at some point in time. And that fact makes nuclear energy a non-renewable energy source. But it doesn't fit with fossil fuels perfectly from the standpoint that it is not a combustion reaction. It's a fission reaction. So that's why we have this diagram of fission. We fire a neutron at an unstable uranium-235 nucleus. That breaks that nucleus into pieces, and you can see those fission fragments come out. Those neutrons fly out and hit other nuclei. They break them, and it's a chain reaction that releases tremendous amounts of heat. And so how does the nuclear energy work? Well, it's the same process as fossil fuels, except for we're not combusting anything to make heat. We're doing this fission reaction. It generates millions of times more heat, more energy per unit of weight compared to coal. So it's extremely efficient. But then what we're doing with that heat is just turning water into steam. That steam is spinning a turbine. That turbine is powering a generator, and there's our electricity. And so because of this, all that's being produced by this reaction of fission is heat. We're not releasing PM, SOx, VOx, NOx, or carbon dioxide or methane. So from an emission standpoint, It's a great alternative to fossil fuels due to no air pollutants, no greenhouse gases. It does have some really big drawbacks, though. Those that include radioactive waste. So the uranium-235 is in fuel rods. When those fuel rods are done, unfortunately, you can't just throw them in the dumpster. And you certainly can't just dig a hole in the ground and throw them in there. They're extremely radioactive, so they give off particles of radiation. Those radiation particles can cause genetic mutations. They can cause cancer in people, in animals. They can contaminate the soil and linger there. Same thing in the water. So they have to be stored oftentimes in like lead containers or buried underneath mountains so that that radiation is contained. And then finally, there's something called thermal pollution. This is when really hot water from the core of the reactor is returned to a nearby, river or stream, and that's going to lead to the water getting really hot and the dissolved oxygen level dropping and something called thermal shock. So nuclear is this complex, not always super well understood, non-renewable, but non-emitting energy source. So it fits right into this kind of weird middle ground between fossil fuels and renewables. Next, we're going to take a look at solar here, which is probably the best known renewable energy source, but there are many types of solar, and that's an Achilles heel of many APE students is they forget that there's different kinds. So let's take a look at those different kinds. We have passive solar. Passive solar is just the idea that we can like heat water or heat a building with the sun, or we can put, a deciduous shade tree up on our house or next to our house. I want to plant it on the roof. And in the summer, it will block the sunlight so the home stays cooler. But in the winter, it will drop its leaves and allow more sunlight in, and that will heat the home in the winter when it's colder. And so passive solar, think of it as just like taking advantage of the sun's energy or blocking the sun's energy as an energy source, oftentimes as a heating source. Then we have what we know as solar panels, but the technical term for those and the term you're likely to see on the AP exam is PV cells or photovoltaic cells. So when you see PV cells, you just have to think in your head, oh, solar panels. Even with solar panels, though, there's very different ways. There's very different ways that they can be used. So they can just be put on top of someone's home. That's probably going to produce only electricity for the individual building or the home itself. It might produce a tiny bit of excess electricity that can be sold back to the grid. You can generate a credit for your home or for your business by producing extra, kind of like extra credit in a class. But that's not quite the same as a solar farm. So take a look at this little picture off to the right. We have a solar farm, which is, generally, hundreds, if not thousands of PV cells or of solar panels out in a field somewhere. And they're really being optimized. They're being turned usually to consistently face the sun. That's going to power cities. So that's like an industrial scale. And we have to be really clear which one we're talking about. A solar farm has the issue of potentially destroying habitat, especially if it's in the desert, which is where a lot of them are built. But if we put, rooftop solar, that's not going to destroy any habitat, destroy any land, but it's also not going to be a commercial grade option. It's not going to produce, the megawatts needed to power cities. It's usually just powering the building that it's mounted. And then finally, we have what I think is the least well understood form of solar energy, and that's CST, concentrated solar thermal. It's very different than PV solar cells. They're not actually generating electricity directly from the sun's rays, which is what the PV cells do. They have a semiconductor that actually generates a flow of electrons just due to the sun's photons that are hitting it. But in a CST, it's basically a bunch of big mirrors, which we call heliostats, and they're focusing all of the sun's rays on a central tower. You can see that in the diagram here. It's called a solar receiver. And so what we have is cold water, or sometimes it's even like a salt mixture that's capable of getting extremely hot. That is piped up into the solar tower. All of the sun's rays are concentrated from the heliostats, and they turn that liquid into a super, super hot, like molten hot, medium basically. And then it's going to be passed through a boiler where it'll heat water. And of course, now hot water becomes steam. Steam turns a turbine, powers the generator, we have electricity. So hopefully you really have that sequence down now. But that is a different type of energy than PV cells, which are just creating a direct electrical current from the sun's rays. So let's take a look at hydroelectricity next. Hydroelectricity is another instance of a renewable energy form where the main thing we think of is a hydroelectric dam, which is sometimes called water impoundment. But we also have two other methods, run of river and tidal energy. So in a dam, which is what we're familiar with, we build this huge concrete wall in the middle of a river. It's going to create a reservoir, and that reservoir is critical because it builds up this huge water pressure that forces water down through the intake channel. You can see that at the bottom of the diagram. It's going to spin a turbine. The turbine powers a generator, and now we have electricity. And it's that actual flow of water that spins the turbine. In a run-of-river system, same idea, but we're not building up a reservoir quite in the same way. What we're doing is pushing that water through an alternate route, and that's flowing through a powerhouse, which has, a turbine and a generator, but it's mostly the natural flow of the river. And then finally, we have what I consider the least well understood form of hydroelectricity, and that's tidal energy. So this can only be done in areas that are near the ocean. And basically what happens is you set up kind of a gate or like a concrete, barrage or gate. It's not accurate to call it a dam. It's not a dam because it's not in a river. But what happens is when the tide moves in, it flows past the turbine in one direction. And then when the tide moves out through the gate, it moves past the turbine in the other direction. Spins the turbine powers a generator. Now we have electricity. Couple drawbacks of dams, especially that we should be aware of, is they block upstream salmon migration. So salmon are not going to be able to swim upstream and reproduce or spawn. So that's a big problem for the salmon themselves, but for the species that eat them, for the humans that like to fish them. And it's also going to block, though, the downstream flow of sediment. So what happens is you can see in this picture here, sediment is going to build up on the dam. And not only does that decrease the amount of electricity the dam can produce, but it robs the downstream habitats of the sediments they need. And that's an important critical element to those downstream habitats. We're going to take a picture, we're going to take a look at a picture of this in a second. But two things I want to point out. You should really get comfortable using the phrase upstream and the phrase downstream when you're talking about a dam. Super important that you refer to downstream as the area below the dam where the water is flowing through the dam, and upstream as the area behind the dam, or where the water is flowing to the dam. That would be upstream and downstream. Really important to use those directional terms. So here's what I mean by that. When we look at a free-flowing river with no dam, we have the movement of sediments, we have the movement of fish that are able to go upstream to spawn in these rocky stream bed habitats. But when we have this bottom picture, we have a dam that's built up. Now we have what's called impounded sediment. So the sediment builds up behind the dam because it can't go through. Then we no longer have the rocky stream bed that used to be there. So macroinvertebrates have lost their home. We can get algae blooms because the water gets hotter because now it's cooling up and the sun's just beating down on it all day. It has an increased surface area. There's this huge lake where there used to just be a little river. That leads to the water evaporating faster. There's so many issues with a river when it's dammed. And as you can see, the fish don't feel too thrilled about the dam. They have something to say when they run into it there. So a lot of issues going on when a river is dammed to create electricity or just for flood control or any other reason. Next, we have geothermal. Geothermal is another tricky renewable because it's not available everywhere. It's only available where the mantle of the earth, which you can see as number 1 in this diagram, the magma. We can only use geothermal when the magma of Earth's core, or when the heat from Earth's core heats the magma in the mantle, and that magma is close enough to the surface. And so what's going to happen if we look at this map of the United States is we're going to see where the temperature at 7.5 kilometers underground is hot enough essentially for geothermal. The reason it can only be done in these places is it involves drilling a well down in the ground, piping water down into that well. That heat from the Earth's core, from the magma, that's going to turn that water into steam. And at this point, I really hope you can complete the steps. Steam turns water into, okay. I hope I can complete the steps at this point. Heat turns water into steam. Steam powers the turbine powers a generator, and the generator creates electricity. It's been a long week, everybody. Spring break is right around the corner. So again, a poorly understood, oftentimes, and overlooked source of renewable energy. Take a look at the map. What you'll notice is that the most active spots for geothermal are going to be out in the west, kind of near California, where there's a fault boundary. That's going to play a role in how close this magma is to the surface and how likely it is to be able to use geothermal. What's nice about it is it doesn't emit nearly as much CO2 as fossil fuels, no air pollutants, so no PM, SOx, NOx, carbon monoxide, VOx, and it's renewable. Cons or drawbacks is that if it's not properly vented, hydrogen sulfide can be released. Hydrogen sulfide is very toxic to humans, so it has the potential to be a really problematic workplace if it's not vented properly. And then the other drawback is it costs so much money to initially drill down, 7 kilometers into the earth, that it sometimes is cost prohibitive, and again, only available in certain locations. So make sure you know those things about geothermal. Kylie says salmon cannons. Yes, Kylie. It's like you went ahead in the slide somehow. It's coming up in a second. The moment you've all been waiting for. Salmon cannons, one of the one of my favorite apes topics. Before we get there, though, we have to wrap up with wind energy. So in wind energy, we just use the kinetic energy of the wind. That's going to turn a turbine, which is mechanical energy. And that mechanical energy of the turning turbine powers a generator. The generator is able to take the mechanical power, convert it to electrical power, and now we can run our homes and all of our devices. Some drawbacks here is that it is going to be intermittent. That means it's not always there. And so if it's not windy, we're not producing electricity. It is more consistent than solar, but it still has the intermittency issue. Another drawback is that it can kill birds and bats, especially large migratory birds that have to fly across the Midwest or areas where we're likely to find these wind turbines. And then I have an eye roll emoji next to this because it's in the APES course and exam description from the College Board. It's been on scoring guides, but a drawback has been that people consider them to be an eyesore, and that some people consider them to be too loud. I don't know. It's technically factual information. I just think they're so neat. They look cool to me. I don't have to live near one, so maybe I would feel differently if I always looked out my backyard and saw it. But you should be aware of those potential answers on an FRQ. Some advantages, some reasons you might want to turn to wind power if you're a community that wants energy that doesn't release air pollutants would be just that. They don't produce any air pollutants or greenhouse gases. The other nice thing is they can share land use. So you can put them in an area where you're growing wheat potentially, or where you're raising animals, livestock, so they can share land use. They don't dominate land use in the same way that solar panels do or that, a coal-fired power plant does. So some big advantages to wind. All right, we're coming down the home stretch here, wrapping up with some go-to FRQ energy answers. So what you'll notice if you look at last week's video is these are all similar categories to last week's video, but what I've just clarified here is that anytime we're talking about renewable energy, we can talk about the reduction of air pollutants, climate change, and habitat destruction. Why is that? So we should look at the bold text here and see that renewable energy, wind, hydro, solar, you could throw geothermal in there. They don't release air pollutants. So we're going to reduce the amount of ozone because we don't have NOx. We're going to reduce photochemical smog, acid rain. We're going to reduce respiratory irritation in humans. So renewable energy can decrease air pollutants across the board and has a huge host of environmental benefits. Let's look at climate change now. We know that fossil fuels release carbon dioxide. Remember, follow the carbons. Fossil fuels are hydrocarbons. You combine it with oxygen and burn them, we get CO2. We know that leads to global warming. So if we use renewable sources of energy, we're not releasing CO2, we're not releasing methane, and so we're not contributing to climate change. And that's a huge advantage environmentally. Then we look at reduced habitat destruction. So to produce fossil fuel electricity, not only do you need to build the actual plant itself, but you need to mine the coal. You need to frack for the natural gas. You need to, extract petroleum from tar sands or from, parts of Alaska from the ocean. And so you have all of these different habitats that can be disrupted by the roads, the equipment, all of the infrastructure, just the clearing of vegetation and land to get at the coal. When you use renewable energy sources, I want to be clear, they do cause some habitat destruction. You have to still mine metals to create a wind turbine. You have to mine silicone to put into your solar panel or some form of semiconductor. So there's no such thing as a free meal or no such thing as a free lunch, as they say, but renewable energy sources drastically decrease the mining for fuel because there isn't mining for fuel. Once the wind turbine's built and generating electricity, there's no habitat destruction. Once the solar panels are up and operating in the field, you're not continually mining new fuel to put in them as you are with any fossil fuel. And then finally, the moment that you've all been waiting for, the moment that Kylie saw coming, 3 slides to go. So shout out to Kylie. She must have a great APE teacher, or she must just be a great APE scholar. But we need to know this little tidbit, this fun nugget, I'll say, of APE's knowledge, which is fish ladders. Fish ladders are these really neat inventions. They're basically steps where the fish can flop their way up and around a dam. I live in a city called Grand Rapids. There are some fish ladders in Grand Rapids on the Grand River. Our school is actually named Grand River. So the river that our school is named after has a fish ladder built right into it. And it's downtown. You can go check it out if you're one of my students. It's really neat to see. I've never actually seen a fish jumping in it, but I'll have to go at the right time of year and try to catch the migrating species. And then the salmon cannon is like this newfangled crazy invention where you can see they're basically catching the salmon, loading them into the cannon. And the cannon is like that big canister transport machine that your parents use at the bank. I don't know if you guys ever remember that as kids, like sitting in the back seat of your car and you ask your mom or your dad, ask them to put Smarties in the bank canister thing when your parents sign their check and they put it in the canister and it goes and it like shoots the tube up. That's the salmon cannon, but for fish. So Kylie, it looks like you have Miss Mangano. So give her a shout out when you see her. Tell her, she's doing a great job if she's teaching about the salmon cannon, because it's just one of the joys of AP Environmental Science is seeing these salmon blasted up and over the dam. So there we have it. That is about what I have for you guys today. I think we'll just wrap up by reminding you about the link tree. The link tree has everything organized all in one place. I love it because people used to ask in the comment section of videos, oh, where can I find the slides for this? Oh, do you have any review guides? Do you have Quizlet sets? And it's all in here now. So if you click on this, I think John has showed this plenty of times before, but if we click on this, hopefully it opens up. Here, it might take a second to load, but you're going to see all of the resources that I have publicly available for people, and it's taking forever to load, so you'll just have to take my word for it. Check it out in the description to this video, but it does have, there we go, right on cue. It has really everything, that I think you need to be well prepared for the exam. So obviously, the Environmental Science YouTube channel, we've seen that. All of the note slides in those videos are here. Targeted reviews are going to help you as you study. They're basically mini quizzes you can give yourself, see how you're doing on them. You've got the Environmental Science Review Instagram, the task verb sheet, an experimental design FRQ guide, 1-page basically cheat sheets, all sorts of things. So check these out. They are what I really highly recommend you use as you start to review for this exam. So thanks so much for showing up tonight, guys.
Great. And Jordan, it's been such a great session. Let me I'm going to go ahead and
thanks, AG. Thanks, Samantha.
Yeah, it's so great that this group of regulars is back. Una, Samantha, AG, Kylie, everyone. Thank you guys for coming. We hope that this has been so valuable. Jordan, as the season comes along in the coming weeks and months, we know a few things are coming. On April the 8th, the College Board's going to let us download digital software. We know that the recording of this session is going to be posted to our YouTube channel. Are you going to be doing any, have you scheduled yet any lives or anything on your Instagram page or YouTube page? Or should we follow you and find out more information?
There you go. The answer is yes. I certainly plan to do more review. We just finished 6 today, so I don't see any reason why we shouldn't do 7, 8, and 9 over the course of April and early May. I have to figure out what day makes the most time. What makes the most time? I'd have to get to spring break if you can't tell.
Yeah, but that's right. We got spring break and Passover and Easter and all the things coming up. So one thing I will say, Jordan, is for everyone here, let us know other ways that we can help you out. I'm going to be going live in just a few minutes, going over how to hack your study plan and get all that set up. But
Yeah.
also, Jordan, one thing we're talking about doing that we could do is go live on Saturdays throughout the month of April. We did it last year. We called them Saturday sessions. They were a lot of fun. So we'll get to work on this, guys, but definitely be in touch with us. Stay focused on what Apes versus Everybody is doing on Instagram, what Marco Learning is doing on Instagram. And that's the best way to be in touch with us. So Jordan, thank you so much. Any other parting thoughts or words before we wrap up?
Rest and recharge over break, you guys. It's been a crazy year. I know, looking at the chat, seeing the people that are here, I know these are super dedicated students. Cut yourself a tiny bit of slack this break, relax, recharge. It's a marathon, not a sprint. And we're coming down the home stretch, but we're not quite in that mode where you kind of just, bury your head and sprint. So save some stamina. We've got to make it down the home stretch. So genuinely try to unplug for a bit and take a little bit of a break to kind of rest and recalibrate. And then you come back from whenever your spring break is. And, at that point, if you're taking an early exam, you're down to like 6 to 7 weeks. If you're taking a later one, it's like, 9 to 10, but we're pretty much coming down the home stretch. And then those last couple of weeks, you can start to sprint, but we need to maintain, some sanity going through the home stretch. So I know, as you guys can tell, what is time? When are dates? Like, I'm so excited to unplug from this wild month that has been March, but I'm very excited to come back in April after some very restful time and hit the ground running with 7, 8, and 9. And I'm just so excited for exam prep this season. I got to it very late last year. As anybody who's been here from day one knows, I put up an exam review video like 2 days before the exam. So it feels good to be here kind of through the whole process. So I'm just so excited to continue reviewing with you guys in April and May.
That's awesome. I look forward to it, Jordan. Have a great break, everyone. Be